We're going to find all of the antiderivatives of this function, and whenever we say all of the antiderivatives, that means the same thing as the integral. And before we work this problem, let me mention a couple of things. Recall that if we took a derivative of x cubed, we would take that power, we would multiply it out in front of the function, we would reduce that power from a 3 to a 2, and we found that derivative using the power rule. With an antiderivative or an integral, we're going to reverse that process. The notation that we use is we use this symbol right here. Every integral comes along with what we call a differential. In this case, that's going to be dx. And that just tells us that our variable that we're integrating with respect to is x. And since we're reversing this differentiation process, the integral of 3x squared should be x cubed. And whenever we integrate, we always end up with a plus c on the end of our answer. A little bit of vocabulary, the function that we're integrating is called the integrand, and this plus c is just some constant. And we can see now that if we took a derivative of this x cubed plus c function, we would get the 3x squared back. So this differentiation process and this integration process are reverse processes. Let's look at this example to see what just happened. Well, we were integrating 3x squared, and we see that our answer was x cubed plus c. What happened there was we added 1 to the power on x, and then we divided this expression by that new power on x. We divided this 3 by 3. That just gave us a 1 right here, so that constant went away. And then, of course, we add a plus c to the end of our integral. Okay, now let's generalize a little bit. We want to take a derivative of x to the n. You see that is a power rule. Now, if we wanted to write down a general rule for the integral of x to the n dx, well, what we do is we add 1 to the power on x, and then we divide by that new power on x. We add a plus c on there, and what we have is a power rule for integration. And this is what we're going to use to complete this problem. To find the integral of this function, we need to first rewrite this function in a slightly better form. We're going to rewrite it as negative 26 times y to the negative 27th power. Now that it's in this form with a variable to some power, we can use this power rule. We're going to integrate this function, and often we name the integral of a function with a capital letter. This constant from the original problem carries down, and what we're going to do is we're going to take this power on y and we're going to add 1 to it. So negative 27 plus 1 gives us a power on y of negative 26. But the power rule says that we need to divide this result by this new exponent. So we're going to divide this result by negative 26. And you can see that those negative 26's cancel. That just leaves us with a final answer of y to the negative 26 power. Of course, don't forget that with our integrals, we need to put a plus c on the end. And we're going to check our answer right down here. We can check to make sure that we got the right integral by taking a derivative of our result. The derivative of y to the negative 26th is negative 26y. And if we subtract 1 from that power, we get negative 27th power. The derivative of a constant is just 0. And you can see here that we got back our original function. That's what we wanted, so this thing checks out. This is our final answer right here. And this problem is finished. I'll see you all next time.